Okay, so we're going to talk about how we use the tangent, sum, and differences formulas, okay? The tangent sum formula says that if you have tangent of angle A plus B, this is evaluated by doing the tangent of A plus the tangent of B divided by 1 minus the tangent of A times the tangent of B. And the tan difference, the tangent of A minus B, is just like the sum formula. You just swap the plus and minus signs. So this is the tangent of A minus the tangent of B over 1 plus the tangent of A times the tangent of B. Okay, so whenever we're evaluating tangents, you have to do y over x, right? So we're going to just make a quick reference chart for whenever we have a half divided by square root of 3 over 2 and so on. All right, and it'll just make all the problems quicker for us later. So if I have a half divided by the square root of 3 over 2, that's 1/2 times 2 over the square root of 3. So these 2's are going to cancel each other, leaving me with 1 over the square root of 3. So, and also start to notice that if you have this denominator, we'll cancel this denominator if they're the same. Right, so the denominators cancel the denominators. Can I leave a square root in the denominator? No. So what do I have to multiply this by?
Square root of 3.
Over the square root of 3. So this is the square root of 3 over 3.
That's how I got it.
That's it.
So anytime that we have a half divided by the square root of 3 over 2, we can just quickly know that that's square root of 3 over 3. Now, and if one of them is negative, it would be negative. If both are negative, it's positive again. Okay, square root of 3 over 2 divided by 1/2. So just like in this last one, think about this. If I were to flip this half, this 2 and this 2 are going to cancel each other, right? So the denominators can cancel the other denominator. So that's just square root of 3 over 1, which is square root of 3. All right, 1 divided by 0. Can you divide by 0? No. So this is undefined. Zero divided by 1. Can you divide 0? So not divide by 0, but can you divide 0? Yeah, you can. So 0 divided by 1 is 0. And finally, the square root of 2 over 2 divided by the square root of 2 over 2. Yeah, it's the same thing in the numerator and denominator, so it's just 1. All right, so this will be our quick reference chart. Okay, we're going to simplify, and then we're going to evaluate the tangent of 115 plus tan of 20 over 1 minus tan 115 tan 20. So if I'm asking you to simplify, I'm saying, okay, where did this come from? What sum or difference did this come from? Because I can't look up 115 or 20 degrees on the unit circle. They're not there.
That's very true.
So is this a tan sum formula or a tan difference? It's a sum because the plus is in the numerator. So this came from the tangent of 115 degrees plus 20 degrees. So right now I'm in the simplifying stage. So that's just the tangent of 135 degrees. Okay, so that's simplified. Now let's evaluate. The tangent of 135 degrees. To do this, I go to my unit circle, 135 degrees. Tangent is y over x. So this is the square root of 2 over 2 divided by negative square root of 2 over 2 on a reference chart, we just saw that square root of 2 over 2 divided by itself is 1. And since one of these is negative, this would be negative 1. So this is simplified, this is evaluated. So this is whenever you're given it in the sum formula and you want to work backwards. From now on, we're going to go the other way. So now we're going to use the sum or difference of tangent to figure out these angles that aren't on the unit circle. So the tangent of 255 degrees. So 255, there's multiple ways I could do this. I could do 225 plus 30. I'm going to do 210 plus 45. Just because I want to do it. So, okay, so this is the same thing as the tangent of 210 degrees plus 45. Alright, so I have to set that up as the tangent of 210. Since it's a sum, I put plus the tangent of 45 divided by 1 minus those two angles, or the two tangents of those angles multiplied. So tangent of 210 times tangent of 45. Okay, now to reduce the number of steps that we use, we're going to have to use that reference chart that we just made. So if I want the tangent of 210 degrees, I go to 210. The tangent is the y over the x. So negative 1/2 divided by negative square root of 3 over 2. So negative over negative is a positive. So look at your reference chart for whenever you have half divided by square root of 3 over 2. That comes out to the square root of 3 over 3. Okay, plus the tangent of 45. So 45 degrees, it's square root of 2 over 2 divided by square root of 2 over 2, just 1. So now, just 1 minus those angles again. Those numbers again. Square root of 3 over 3 times 1. So just in case you're wondering where I got these things from, we have to remember that tangent is always the y-coordinate divided by the x-coordinate. So whenever I went to 210, I looked at the y-coordinate, negative 1/2, and I divided that by negative square root of 3 over 2. And then instead of having to work all that out, I made a reference chart a second ago for whenever you have a half divided by square root of 3 over 2 is square root of 3 over 3. Alright, so back to the problem. I can't have fractions in the numerator and in the denominator. So I'm going to have to make a common denominator in the numerator and in the denominator. So this is square root of 3 over 3 plus, if I want 1 to have a denominator of 3, that's just 3 over 3. Over, same denominator, 3 over 3 minus the square root of 3 over 3. Okay, so combine the numerators. 3 plus the square root of 3 over 3 over 3 minus the square root of 3 over 3. They both have a denominator of 3, so what's going to happen to those denominators?
Cancel out.
We're going to cancel. And I have 3 plus the square root of... Ooh, that looks like an and sign. Plus the square root of 3 over 3 minus the square root of 3. Okay, so in this first example, I had you come up with what two angles you needed to use. Here, I'm telling you what two angles to use, 4 pi over 3 and pi. So this is a difference formula. I want to do the tangent of 4 pi over 3 minus the tangent of pi over 1 plus the tangent of 4 pi over 3 times the tangent of pi. Okay, so to find the tangent of 4 pi over 3, I look at the unit circle, I go to 4 pi over 3, and that'd be the y over the x. So negative square root of 3 over 2 divided by negative 1 over 2. Go back to those problems that we did earlier. Whenever you have a problem like that and it's negative over negative, that's just the square root of 3. Okay, minus the tangent of pi. So I would go to pi. That'd be y over x. So 0 over negative 1 is 0. All of that is divided by 1 plus the tangent of 4 pi over 3 is square root of 3 times the tangent of pi of 0. Well, square root of 3 times 0 is 0. So I have the square root of 3 minus 0, which is the square root of 3, over 1. So that's just the square root of 3. Alright, so sorry that I don't have an alpha and beta in my little font characters. So we're going to find the tangent of alpha plus beta. And we're given that the cosine of alpha is 4 over 5, the sine of beta is 5 over 13, alpha is in quadrant 4 and beta is in quadrant 1. So the first step in solving any of these type of problems is to draw the triangles. So the cosine of alpha is in quadrant 4. So alpha is in quadrant 4. Remember that the angle comes out of the origin. Okay? You're never going to have a triangle like this. Okay, so yeah, this is the wrong type of triangle. The cosine of alpha is 4 over 5, so that's the adjacent over the hypotenuse. So we use Pythagorean theorem. What's the third side of this triangle? It's negative 3. And why is it negative? Because it's in quadrant 4, so the y value is negative. Okay, beta's in quadrant 1. And the sine of beta is 5 over 13. So sine is opposite over hypotenuse. Yeah, this whole time we're using SOHCAHTOA. Okay, so from our Pythagorean triples, what's the third side of this triangle? 12. Okay, good. So now I can find the tangent of alpha plus beta because the tangent of alpha plus beta is the tangent of alpha plus the tangent of beta over 1 minus tangent of alpha times the tangent of beta. So tangent from SOHCAHTOA is opposite over adjacent. So the tangent of alpha would be the opposite, negative 3, over 4, the adjacent. Plus the tangent of beta, opposite over adjacent, would be 5 over 12. Divided by 1 minus those two things multiplied together. Alright, so we're going to have to find some common denominators. What's the common denominator between 3/4 and 5/12? 12. So, to get to 12, I'm going to have to multiply this first fraction by 3 over 3. So that's negative 9 over 12 plus 5 over 12. All divided by 1 minus, or actually we have 1 minus this negative, so this is going to turn into 1 plus. Multiply the numerators, multiply the denominators. Now, if I'm going to end up adding 1 plus 15 over 48, I'm going to change this 1 to 48 over 48. That way I can add the fractions. So I have negative 4 over 12 divided by 63 over 48. Alright, I'm dividing fractions, so I'm going to flip that bottom fraction and multiply. Now, negative 4/12, does this reduce?
Yes.
Yeah, it's a negative 1/3 times 48 over 63. Now I have to check, is there anything else that can reduce? So does 3 go into 48? The quickest way to check if it does go into it, 4 plus 8 is 12. 3 goes into 12, so 3 goes into 48. How many times does 3 go into 48?
16.
Yeah, 16. So this reduces to a 16. So I have negative 1 times 16 over 63 is negative 16 over 63. Alright, for this last one, we're going to prove that tangent of beta minus 7 pi over 4 is equal to tangent of beta plus 1 over 1 minus tangent beta. So this is a difference. So I can expand this to be tangent of beta minus the tangent of 7 pi over 4 over 1 plus the tangent of beta times the tangent of 7 pi over 4. Now I'll have to leave tangent of beta, but I can find the tangent of 7 pi over 4. So minus the tangent of 7 pi over 4. 7 pi over 4, here's 7 pi over 4. That would be the y divided by the x. So negative root 2 over 2 divided by root 2 over 2. It's negative 1. So over 1 plus tangent of beta times the tangent of 7 pi over 4 was negative 1. Well, look, tangent of beta minus negative 1, that's the tangent of beta plus 1. And tangent of beta times negative 1, that's 1 minus tangent of beta, which is what I was trying to show. We proved it. Goodbye.